Okay, this is a super important topic. This is about normal distributions, and this is where we're going to learn about the 99, the 68, 95, 99.7 rule. Okay, so data distribution is the way data values are clustered. So if we look at these three data values, this is called skewed right, skewed left, and a normal distribution. So let's say, for example, let's say this is, the average age in a country, right? This is a histogram. So in this country, if this was younger and this was older, this would be a very young country. There's a ton of babies being born, way more babies than adults. If you look in this country, if this was all the old people, this means that the country is getting really old and no new babies are getting born. This is not a very good example, but there is different instances where you get skewed right, skewed left, and a normal distribution. So the trick to think is this is where the tail is, right? So the tail is on the right side, and the tail is on the left side. Okay, but the most important one is the normal distribution, and that's what we're going to talk about now. So a symmetrical bell-shaped curve defined by the mean and the standard deviation of the data set. So the area under the curve represents the probability with the total area equal to 100%. Okay, so this is the 68, 95, 99.7 rule. This is super important, right? Make sure you pay attention. So, approximately 68% of the data falls within one standard deviation of the mean. Approximately 95% of the data falls within two standard deviations of the mean. And approximately 99.7% of the data falls within 3 standard deviations of the mean. So, it can go on either side, right? So if it's within one standard deviation, that's one standard deviation less and one standard deviation more. So this whole thing is 68% of the data, which makes sense because it's a big chunk, right? If you think about a curve, right, most of the volume is in this middle section because it's so high, right? And then if we go even further, sort of hard because there's not that much room, right? Within 2 standard deviations, we have 95%. So if we think this tail over here and this tail over here is only 5%, right? So this whole thing is only 2.5%, right? If we were to cut this in half, this whole side is 50%. So we want to be able to break it up. So if this whole thing is 68%, remember a standard deviation is symmetrical, right? The center of the axis of symmetry, which is another vocab word, is right here at the mean. So if this is 68, that means this right here is 34%. This is 34%. And then here, if this whole thing is 95%, we need to figure out what these missing pieces are. So let's use our calculator, right? So we know that this piece plus this piece, let me erase this. So these 4 pieces together add up to 95, right? But we already know 2 of the pieces. So let's do 95 minus 34 minus 34. So now we have these 2 pieces, and they're equal because this is symmetric. So this is going to be 13.5%, 13.5%, right? And now we know that this whole thing is 99.7%. So 99.7 minus 95. These sections here add up to only 4.7%. So this one is 2.35%. 2.35%. And then right here is this tail end. If these all, right, within 3 standard deviations, if this is all 99.7%, that means these two tail ends is only 0.3%. So this right here is 0.15%, and this is 0.15%, right? So if we were to add these all up, right, let's do it in decimal form. So 0.15 plus 0.0235 plus 0.135 plus 0.34 plus 0.34 plus 0.135 plus 0.0235 plus 0.0015 equals 100, right? So this whole thing is 100%, but each one is broken down, right? So we need to be able to think about percentages of things happening on a normal curve. Let's go through some examples, and I think you'll understand it better. Okay. So let's set up our normal curve, draw and label normal distribution curves, and answer the questions. The weights of the 50 football players are normally distributed with a mean of 178 pounds and a standard deviation of 8 pounds. Right? So if our mean is 178 and our standard deviation is 8, so 178 plus 8 is going to be 186, plus 8 is 194, plus 8 is 202. And then 178 minus 8 is 170, minus 8, 162, minus 8, 154. So most of the players are around 178, but there's some players that are all the way up to 202 pounds, and there's some players that are all the way down to 154 pounds, right? And let's label these right here. We have 34%, 13.5%, 2.35%, and then 0.15%, right? Because this is 68, this whole thing is 95, 99.7, right? Let me shade it. So shaded part is 68. Now I add these two to get to 95. Now I add these two to get to 99.7, right? The 68, 95, 99.7 rule. Okay. What percent of the players weigh between 178 and 194 pounds? So if we look here, between 178 and 194 is this percentage. So we're going to do 34% plus 13.5%. And that gives us 47.5%. Okay, what is the probability that a player weighs at most 170 pounds? So at most means x is less than or equal to 170. So if we look here, we're going to add 0.15% plus 2.35% plus 13.5%, right? These three sections right here, because it's 170 and below. So 0.15 plus 2.35 plus 13.5 is 16%. What is the probability that a player weighs less than 62 pounds or greater than 194? So x is less than 162 or x is greater than 194. So if we think about it, between 162 and 194, that is our 95 mark, right? So all the stuff on the outside is going to be 5%. right? We could add these 4 up and we get 5%, or we could think 100% minus 95%. Okay, how many players weigh between 170 and 186? So this is all within 1 standard deviation, so we know that it's 68%. Oh, it's how many players. Okay, so it's 68%, but there's 50 players. So 0.68 times 50 is 34 players. All right, so you got to make sure you read carefully. The rest of these percent, probability, and this is players. Okay, so this is how we break it down, right? If it's a normal curve, you can answer all these questions as long as you have the mean and the standard deviation. Okay. Let's fill this out again. So a set of 120 test scores are normally distributed with a mean of 82 and a standard deviation of 5. So we're going to do 87, 92, 97. One standard deviation, 2 standard deviation, 3 standard deviation, -1 standard deviation, -2, -3. And we have 68%, 95%, and 99.7%. I'm going to do these in different colors just to really highlight it. Do I have another highlighting color? It's purple. Which means this is 34, 34, and let's look back. 13.5. 2.35, 0.15. So you should always be able to make this table as long as you can remember 68, 95, 99.7. And so you can set this table up for yourself when you're making when you're answering these questions. Okay, what percent of the scores are between 72 and 87? So that's these three, right? 72 to 87. So we're going to do 13.5 plus 68, 81.5. What is the probability that a score is greater than 77? X is greater than 77. So we have all of this, right? I'm going to erase this a little bit. And we have these guys. That's all greater. So let's add them all up. We have 34 plus 34 plus 13.5 plus 2.35 plus 0.15. 84%. What is the probability that a score is less than 82 or greater than 92? So less than 82, we already know, since 82 is the halfway point, we already know less than 82 is going to be 50%. And then greater than 92 is going to be 5%. No, 2.5%. So 52.5%. About how many students scored outside 2 standard deviations of the mean? So we already know, right? 2 standard deviations is 95. So outside of standard deviations is going to be, outside of 2 standard deviations is going to be 5%. So 5% of 120 is 6 students. You could also think like 5 over 100, that's percentage, equals x over 120. Same thing. Oh, I wrote that really small. Okay, next problem. The price of a gallon of regular gasoline at 75 gas stations across the state is normally distributed with a mean of 205 and a standard deviation of 4 cents. Okay, what percent of gas stations sell a gallon of regular gas for less than 197? It's going to be 2.5%. What percent of gas stations sell a gallon of regular gas for at least 217? Everything but this tail end, so it's going to be 100% minus 0.15%, which is 99. Oh, for at least. So that's not less than, it's more than. So it's actually just the 0.15%. What is the probability that a gas station sells a gallon of regular gas for less than 197 or greater than 205? So where do you know less than 197 from up here? So 2.5%. Greater than 205 is 50%. Because this is the mean, right? And if the whole curve is 100, that means half is 50. So 52.5%. About how many stations sell a gallon of regular gas for no more than 201? So that is x is less than or equal to 201. So I'm going to do, we already know that this is 50. And then we're trying to cut off this piece right here, right? And we want these 3 left. So I'm just going to actually do 50 minus 34. And it's 16%. So 16% times 75, right? 0.16 times 75. It's going to be 12 stations. Remember, we always want units, or else I'll mark off. Okay, last problem. Mrs. Fuller recently tested her 120 keyboarding students to see how many words per minute they can type. The results were normally distributed with a mean of 45 and a standard deviation of 6. So plus 6 is 51, plus 6 is 57, 63, 39, 33, 27. About how many students can type at least 39 words per minute? At least is all of these. So x is greater than or equal to 39. So we have 50% plus 34% equals 84%. So 0.84 times 120 kids equals about 100.8. So you could say 101 kids or students. About how many students can type within one standard deviation of the mean? So within one standard deviation is 68% from the 68, 95, 99.7 rule. So 68% times 120 students equals 81.6. So approximately 82 students. Students need to be in the top 2% in order to be eligible for a national typing competition. If Carla can type 56 words per minute, is she eligible? So the top 2%, right? If we know that this is 2.35% and this is 0.15%, we know that the top 2% is somewhere in this bracket, somewhere between 57 and 63. Carla can only type 56. So she is not in the top 2%. So she is not eligible. No. All right. So please make sure you do the practice problems for these. Make sure that you can make this chart without looking at your notes. Like you do it enough that you can use the 68, 95, 99.7 rule to answer these questions without looking at your notes, because in the quizzes and tests and everything, you're not going to get these notes. You're just going to have to remember it.